Mathematicians, it's Justin again. I'm in my backyard enjoying the sun and listening to the birds. I've got an idea for my next backyard project. A birdhouse. Come on, let's head to my workshop and get started. Okay, I sketched out my birdhouse design, and the base will be a square with an area of 16 inches squared. Before cutting the wood, though, I need to find the length of each side. If the area of the square is 16 square inches, how long should each side be? Just like my garden and pool, the square root of a square's area gives its side length. What's the square root of 16? 16 is a perfect square, and its square root is 4. That means each side of the base will be 4 inches long. I also need to cut 2 square pieces for the roof, each with an area of 20 square inches. We can take the square root to find their side lengths. What's the square root of 20? Ooh, 20 isn't a perfect square, so this won't be as easy as the base. We already know how to find which 2 whole numbers a square root is between, so let's start there. Which 2 consecutive whole numbers is the square root of 20 between? 4 squared is 16, that's a little smaller than 20, and 5 squared is 25, a little bigger. So the square root of 20 must be between 4 and 5. That's a nice estimate, but I don't think it's good enough for my birdhouse. I mean, how am I supposed to know where to cut the wood if the side length could be anywhere between 4 and 5 inches? Looks like we need to explore more about square roots to get a more accurate estimate for this project. Let's try estimating the square root of 14. Which 2 consecutive whole numbers is it between? It's between 3 and 4, because 3 squared is 9, and 4 squared is 16. That's a great start. But now we should visualize this on a number line between 3 and 4. Think of this like a sandwich. 3 and 4 are the slices of bread, and the square root of 14 is somewhere in between. But there are a lot of numbers inside this sandwich, so let's try to narrow it down. Do you think the square root of 14 is closer to 3 or 4? Well, is 14 closer to 9 or 16? 14 is closer to 16 than 9, so the square root of 14 is closer to the square root of 16, which is 4. What does that tell us about where the square root of 14 is on the number line? Yeah, our estimate should be on the right half of the number line, closer to 4. So some good estimates are 3.6, 3.7, 3.8, and 3.9. To write an estimate, we use this symbol. It's like an equal sign, but with squiggly lines, to show that the value is approximate. We read this as the square root of 14 is approximately equal to 3.7. Let's try another example. Estimate the square root of 42. Pause the video here and try this in your guided notes. The square root of 42 is between 6 and 7. And 42 is almost exactly in the middle between 36 and 49. So, for the estimate, choose a number close to the middle between 6 and 7, like 6.4, 6.5, or 6.6. They're all great estimates for the square root of 42. Now, these estimates are useful when we don't need a precise value, but how could we get a more accurate estimate if we needed one, like for my birdhouse? Let's try estimating the square root of 27 to the nearest tenth. To the nearest tenth means we need a more accurate estimate this time. We know the square root of 27 is between 5 and 6 somewhere. Using the strategies we've learned so far, how would you estimate the square root of 27? 27 is between 25 and 36, but it's closer to 25. So the square root of 27 should be closer to 5 than 6. I'm going to go with 5.2 as my first estimate. Since we're estimating to the nearest tenth, I need to make sure that 5.2 is the best estimate. How do you think I could check that? Maybe I can take 5.2 and work backward to see what it squares to. If 5.2 is a good estimate, then squaring it should result in approximately 27. Pause the video here and multiply to check my estimate. $5.2 squared is 27.04. That's so close to 27, but it's a little bigger. But now we can shrink our sandwich. Since 27 is between 25 and 27.04, we now know that the square root of 27 is between 5 and 5.2. We're getting closer. Since 5.2 was too big, let's try 1/10 smaller, 5.1. Pause the video to calculate 5.1 squared. 5.1 squared equals 26.01. That's smaller than 27, so we can shrink the sandwich again. Now we know that the square root of 27 is between 5.1 and 5.2. We've narrowed this down to a sandwich that's between two consecutive tenths. At this point, we can just choose the best estimate. 27 is closer to 27.04 than to 26.01. This means 5.2, which gave us 27.04 when squared, is the best estimate to the nearest tenth. Wow, we can use what we know about square roots, squaring, and decimal multiplication to get a pretty accurate estimate. I think we're ready to tackle the birdhouse problem. Find the side lengths of the birdhouse roof pieces by estimating the square root of 20 to the nearest tenth. Pause the video now to try it. The square root of 20 is between 4 and 5. Since 20 is in the middle of 16 and 25, let's check 4.5. 4.5 squared is 20.25. That's bigger than 20, so the square root of 20 is between 4 and 4.5. Let's check 1/10 smaller. 4.4 squared is 19.36. That's smaller than 20, so we've narrowed it down. The square root of 20 is between 4.4 and 4.5. Now, you might have tried 4.4 first, and that's totally okay. Or maybe you started with 4.3 first and had to go up from there. Also okay. As long as you found that the square root of 20 is between 4.4 and 4.5, your process worked. Now that our estimate is between two consecutive tenths, let's check which one is closer. 20 is closer to 20.25 than to 19.36. So the square root of 20 is approximately 4.5. The roof pieces will have 4.5-inch sides. That's a measurement we can work with. The squares with 4.5-inch sides will have an area of 4.5 squared inches squared. We already calculated that as 20.25 inches squared. Why isn't that exactly 20 square inches? Like we started with. Pause the video to write down your thoughts. Since we estimated the square root of 20, our side length is approximate. It's slightly bigger than the actual square root of 20. The square roots of non-perfect squares are irrational numbers, so their decimals never end, and we'll never get an exact value. But 20.25 is pretty close to 20. I don't think the birds will mind. Thanks to your help estimating the square roots of non-perfect squares, I could finish my birdhouse. We used the same strategy as before to find the whole numbers a square root was between, but now we know how to estimate to the 10th place and multiply to check how close our approximation is. For now, finish up your guide and notes, then complete levels 1 through 3 of the online practice. And as always, keep questioning, keep calculating, and remember, if you're hungry for a good estimate, try making a sandwich. See you next time!